Lesson 9, Solving Counting Problems. So a piano teacher and her students are having a photo taken. There are 3 boys and 5 girls. The photographer wants the boys to sit together and the girls to sit together for one of the poses. How many ways can the students and the teacher sit in a row of 9 chairs for the pose? So we have 9 chairs, but because the teacher, the boy, and the girl have to sit together, it's kind of like we have only 3 options. For the teacher has to sit by his or herself, the boys have to sit together in one group, and the girls have to sit together in one group. Within that group, though, there's one teacher, so there's 1 factorial way that the teacher can sit. There are 3 boys, so there's 3 factorial ways the boys can sit, and there are 5 girls, so there's 5 factorial ways that the girls can sit. So you have 3 events. We're multiplying them together. We have the teachers, the boys, and the girls. So we have 1 factorial times 3 factorial times 5 factorial. Now, that is in the case if they're sitting teachers, boys, and girls. But because there are 3 options here, this itself is 3 factorial as well. So we take this and we multiply the whole situation by 3 factorial because there are 6 different ways that they could be arranged with the teacher, the boy, and the girl. So we're multiplying 1 times 3 factorial, which is 3 times 2, which is 6, times 5 factorial, which is 120, times 3 factorial, which is 6 again. So altogether, there's 4,320 ways to arrange these children, which seems ridiculous for one picture, but there's that many options. Combination problems are common in computer science. Suppose there is a set of 10 different data items represented by A, B, C, D, E, F, G, H, I to be placed into 4 memory cells on a computer. So we have 4 memory cells. Only 3 data can be placed in the first cell, 4 data to be placed in the second cell, 2 data to be placed in the third cell, and 1 data to be placed in the last cell. How many different ways can the data be placed in the 4 remaining cells? So because these are all pertain to each other, it's one separate case, or a single case, we're going to multiply the 4 things together. So when we start, we have 10 items. A, B, C, D, E, F, G, H, I, J is 10 things. So we have 10 of them, and only 3 data can be used in this first cell, so we're choosing 3. In the second cell, because we've used 3 of them, there's only 7 left. So we're taking 7 and we're multiplying by 4, because we're choosing 4 data for the second cell. In the third cell, there's 4 taken away, so we're left with 3. And we want to choose 2, so we have 3 choosing 2. And the last one, we have n is equal to 1. There's only 1 piece of data left, and it has to go in that cell, so we're 1 choosing 1. So here's our formula. We're going to multiply them all together. Remember, this is the same as writing 10 over 3 times 7 over 4 times 3 over 2 times 1 over 1. 10 over 3 is 120. 7 over 4 is 35. 3 choose 2 is 3. And 1 choose 1 is 1. There's only one way to do that. And if you multiply this all together, you get 12,600. So that's how many ways the data can be rearranged into memory cells. Lastly, example 3. How many different 5-card hands that contain at most 1 black card can be dealt to one person from a standard deck of cards? So there's 2 conditions. The first condition is at most 1 black card. So we have 1 black card. The second condition is we have no black cards because it's at most. But there is the option of having no black cards. So what that means is each of these are split into 2. We have 0 black and 5 red. or we have 1 black and 4 red. And because these are 2 different cases, we have to add these 2 together. The case where there's 0 blacks and the case where there is 1 black. So there are 26 red cards in a deck and 26 black cards in a deck. So for the first one, we have 26 black cards. We're choosing none of them. We don't want any. And for the red cards, we have 26 red cards, and we're choosing 5 of them. For the second condition, we have 26 black cards, we're choosing 1. And we have 26 red cards, and we're choosing 4. So that is how we would rate that. This is the same as saying 26 over 0 times 26 over 5 plus 26 over 1 times 26 over 4. This is also the same once you've typed it into your calculator as 26 times 14,950 plus 1 times 65,780. And I wrote this backwards. Altogether, you should get 454,480. So there's so many different card possibilities. That is why gambling is too difficult for you.